As another hint, I will take the same matrix, matrix A, and take its determinant again, but I will do it using a different technique, and either technique is valid. So here we're saying what's the determinant of the 3 by 3 matrix A? And what we can do is we can rewrite the first two columns. So this column right over here, we can rewrite it as 4, 4, negative 2. And then the second column right over here, we can rewrite. So it's negative 1, 5, and 0. And what we can do is we can take the sum of the products of the first three top left to bottom right diagonals. Let me show you. So the product of that, plus that, plus that. I'm trying my best to draw this neatly. And then from that, subtract the top right to bottom left diagonals. So from that, subtract, let me get a color I haven't used, subtract that, and that, and that. So I know it's really confusing with all these things I've drawn, but let's look at the blue ones first. So we have 4 times 5 times 0, 4 times 5 times 0, plus negative 1 times 3 times negative 2, plus negative 1 times 3 times negative 2. Let me put these in parentheses, plus 1 times 4 times 0. 1 times 4 times 0. And then we're going to subtract all of these orange diagonals that go from the top right to the bottom left. So we're going to subtract. We could do 1 times 5 times negative 2. 1 times 5 times negative 2. And then we could subtract 4 times 3 times 0. 4 times 3 times 0. And then we can subtract negative 1 times 4 times 0. Negative 1 times 4 times 0. And now we just evaluate this over here. 4 times 5 times 0 is just 0. Negative 1 times 3 times negative 2 is positive 6. So this is positive 6. 1 times 4 times 0 is 0 once again. And then we have 1 times 5 times negative 2 is negative 10. But then we have this negative out here, so it becomes a positive 10. And then we have 4 times 3 times 0. Well, that's just going to be 0. And then we have negative 1 times 4 times 0, which is just 0. So we're left with positive 6 plus 10, which is equal to 16.